Alright guys, good morning. We're going to go ahead and get started right now with our second section of chapter 11. And that is going to be the chapter on the section of area of triangles and parallelograms. So on section 11.1 we discussed area as it pertains to rectangles and squares. But for today, we're moving on a little bit and talking a little bit more about the area of triangles and the area of parallelograms. What you're going to see is that actually the formulas that pertain to the area of a triangle and a parallelogram are going to be very similar to what we already saw in chapter 11.1. So that's why we went through that section first. But for now, let's go ahead and get started here, guys. Let's go ahead and draw out these scenarios. So the directions say for this problem, draw a figure to represent each of these scenarios. So let's do that. The first scenario, they're asking us to draw a picture of an isosceles triangle with base of 8 and height of 12. So here is an isosceles triangle. Let me see if I can use my little tool here. Let's try this out. Okay, that's not bad. Oh, let me do it a little better. There you go. I like that better. Okay, so that's an isosceles triangle. Our base, we said, was 8. Now this is isosceles, so don't forget to mark the legs as congruent. And then to find this height, guys, remember a height will always be perpendicular to the base, okay? Or just like an altitude would be, okay? Altitude. So this is our altitude right here, or our height, and in this case that height would be 12, okay? So if I was asking you guys to find the area, you guys would eventually now be able to do that. Again, you'll be able to do that once I show you that formula, which I know most of you guys already know. For the next one, a right triangle with a small leg of 8 and a long leg of, small leg of 6 and a long leg of 8. So let's go ahead and draw a right triangle. Okay, alright, here's my right angle. Now it says a small leg of 6. This looks like my small leg. A long leg of 8. That looks like my long leg. And by the way, guys, the one across from the 90-degree angle, I would never call the long leg. This is, if anything, it's called the longest leg, but the proper terminology here, guys, would be the hypotenuse. So here is our hypotenuse. But for now, guys, that's not really too relevant because all they are asking for is for us to draw this particular scenario, and we're done, okay? So if I was looking for the area, again, I would be able to do that because in a second you're going to notice that what's really important in area is also a base and a height. Base and a height, just like it was important for a rectangle. So for this last one, let's go ahead and talk about what this is asking. We want an obtuse triangle this time with the longest side of 10 and a height of 6. So let's go ahead and see if we could draw a scenario similar to this. So let's see. Let's start off with this portion, an obtuse triangle. Automatically, when I think of an obtuse triangle, I think of something like this. Okay? So maybe this is like, I don't know, 110 degrees. So remember, obtuse triangle has an angle that is greater than 90 degrees. And it says its long side, its longest side. Its longest side would be here. Okay? That's across from the largest angle, which we have talked about in previous theorems, the angle side theorem. And then it also is saying that we have a height of 6. Now, question is, well, where is that 6? And guys, really, it all depends on where exactly and what you're using as your base, okay? In this particular scenario, I'm actually going to use this as my base because you cannot define the height unless you know the base. Why? Because, remember, if you have a height to a triangle, it has to be perpendicular to the base. So in this case, if I consider that bottom portion my base, then this here would be my height. This would be 6, okay? So just keep that in mind, guys, as we move forward through this. And one big distinction that I need to make here, guys, is this. That's not the only scenario. You might not always have a height that is inside of the triangle. Sometimes the height is actually going to be outside of the triangle. So let me show you what I mean by that. Let's go ahead and still draw another scenario that meets all of the requirements from this particular prompt. Here is an obtuse angle, or sorry, an obtuse triangle with an obtuse angle right there. So the longest side is still here. That's 10. But here's the issue, guys. What if I thought of this as my base? Where would I actually draw my height? Well, oh, I kind of extended it a little bit too much. Got ahead of myself here. But let's say this is my base. Here's the thing, guys. Don't draw your height here. And let me tell you why you can't draw it here, even though some of you may be tempted to do that. Some people might be tempted to draw the height right there. Problem with that is, guys, remember, this is not really the base portion right here, okay? You are trying to draw it from a vertex, okay? You're trying to draw it from a vertex right here to the opposite side and make it perpendicular to the opposite side. So the right angle is not here. You can't put it there, okay? So let's go ahead and redraw this triangle then. So the problem now is, guys, is this. I can't really draw it there. However, what I can do, remember, okay, I can actually, if I keep saying that I want this to be the base, I have to draw a line that is perpendicular to that, okay? So I'm actually going to go ahead and extend this right here, and now I'm going to draw that right there, okay? This is my height, guys, right here. This is my height of 6. So remember, the height is not always necessarily inside of that particular triangle, guys, okay? So just keep that in mind as we move forward through this. So what is the formula, guys? What is the formula for finding the area of a triangle? Well, you guys, again, may already know this, but here it is. Area is 1/2 the base times the height. If you look closely, this looks familiar because that's the area of a rectangle, okay? Now, what's different? Well, now we have this added portion of 1/2. Well, why does that make sense, guys? And just to give you a quick example, think about it this way. Let's say we have a rectangle. Let me try to draw a nice one here. Say I have a rectangle like that. Let's say this is 6, this is 10. Well, isn't a rectangle just two triangles that are stacked on top of one another, right? And more specifically, two right triangles in this case. But isn't it just this yellow triangle here and this green triangle here? And don't they actually have the exact same dimensions, right? Because opposite sides of a rectangle are congruent, okay? So what's happening here, guys? Well, if I'm looking for the area of a triangle, I'm only looking for one of these, all right? I'm only looking for this right here. Well, okay, if I just want that piece and I don't want this piece, what did I just do to my big rectangle? I just cut it in half. Well, that's where the formula comes in, guys. The area for a triangle is just half of what the area of a rectangle would be that creates that particular triangle. So just keep that in mind, guys. Just a little bit of something to think about as you're moving forward. Again, guys, these formulas didn't come out of thin air, okay? These are derived from certain aspects of the most basic foundations of geometry, okay? And that's why we started with the area of a rectangle and the area of a square, because many of the formulas that are going to come up are actually derived from those two formulas. So let's move on. The next one, we have our area formula for our triangles. So let's go ahead and apply it to this next challenge. So it says find the area of a figure, of each figure, sorry. So I want to find the area of this whole thing. But here's what I'm noticing. This is broken up into two big pieces. Here's one. That's a rectangle. Here's the second. There's a triangle. Okay? Now, do I have everything I need to find those areas? Well, yes, I do. Base times the height for this rectangle. So what is base times height? 6 times 12, that would be 72. units squared. All right. Now, do I have enough information for this red triangle here? Well, yes, I do. Do I have a base? Yes, I do. It's right here. Do I have a height? Yes, I do. It's right here. So my base is 12. Remember, these two have to be exactly the same. All right, because it is a rectangle after all. All right, so we have a base, we have a height. So how do we calculate that? Well, we just learned that the area of a triangle is 1/2 the base times the height. 1/2 times 12 times 3. So the area here in this particular case is going to be 18, if I'm not mistaken. 18 units squared. So now we have everything we need. Whoops. That's the area of this triangle here. So what am I going to do? To find the area of the figure, I am going to do 72 plus 18 for a total of 90 units squared. The area of the entire figure is going to be 90 units squared. All right, let's move on. We're going to go ahead and find the area of the shaded region here. So the only portion I'm looking for is this, guys. Okay, but the reason why we drew this extension over here, right here, is because, again, guys, remember, this is our base. The height has to be perpendicular to that base. So what I just did was extended the base a little bit to find out what the actual height of the triangle was. Okay, now again, I'm not going to include this as part of my answer, but the reason why I want it is because I need to be able to figure out what that is. What is this height? So I can multiply it times the base. All right, just keep that in mind, guys. So let's go ahead and do this. So how would we go about doing that? Well, here's the deal. How much is this? Okay, well, let's see, that's 12. Well, how is that helpful? Well, it's going to be helpful because I can actually, what I could do, you might not see it, it's kind of in disguise here, but what I could really do is just find the area of this big triangle, the full one, and subtract the area of this. So if I can subtract this portion out of there, I would only be left with that area right there. So let's do it. Maybe I'm just talking a little bit too much. It's better off if we just do it together. Okay? So let's concentrate for a second, guys. All right, here we go. If I could only find the area of this red triangle. Well, let's try it. Area of the triangle is going to be 1/2 the base times the height. Do I have the base? Yes. The base is going to be 12. 1/2, 12. Do I have the height? Well, no, I don't. I don't have the height. I need to know what this is. But actually, guys, look at it closely. Okay, look at the big red triangle. Okay, this is actually a Pythagorean triple. Okay, that big red triangle is a 5, 12, 13 triangle. If you didn't know that, guys, then don't worry. Use Pythagorean theorem. But I guarantee you, you will find that this height right here is actually going to be 5. Okay, that height has to be 5 because it's a 5, 12, 13 triangle. So I do know my height. So the area of the red, or the area of the big triangle, whatever you want to call it, is going to be 1/2 times 12 times 5. If I am not mistaken, let me try that one. Try multiplying that out. 1/2. Let's see. 1/2 times 12 times 5. That is 30. Okay. So that is going to be 30 right there. Okay. All right. Let's see here. Let's go ahead and find the remaining portion here. Oops, sorry about that, guys. All right, so let's keep going, guys. So we found the area of the bigger triangle there, but I don't want the whole triangle. I just want this portion. I don't want any of this. So let me erase or delete this green portion right here. Okay, let me delete that green portion. Well, let's find the area of this green triangle, because this is a green triangle after all right here. Do we have a base and a height? Well, yes, we do. Base, height. So the area, whoops, sorry about that. The area of the blue, or sorry, the area of the red, oh my god, sorry, the area of the green triangle is actually going to be 1/2 times the base times the height. Alright, so what would that actually be? That's actually going to be 1/2 times 5 times 5. That is going to be 12.5 if I'm not mistaken. So I only wanted the area of the shaded triangle. So what would I do now, guys? Well, I'm going to take my full triangle, 30, minus the smaller piece that I don't want, 12.5. So 30 minus 12.5, and that's actually going to give me 17.5 units squared. Okay? Alright, so that's how we would do it, guys. We would actually think of this as two separate triangles and just erase the portion of the triangle that you don't want, which in this case was the green triangle. However, I want you to notice something, guys. You didn't even have to go that far, because if you can find out that this is 12, this is 13, and then eventually find that the height is 5, well, guys, check this out. What do you actually have? Well, this triangle here, the one that I originally wanted, has what now? Well, it has a base of 7. It has a height, which we found, of 5 right here. Okay? So I could have actually just done, let me call it the blue one, or the shaded one, doesn't really matter, 1/2 the base times the height. That would be, let's see, that would be 35 times 1/2, or half of 35. That would be 17.5 units squared. Notice these two things are exactly the same. This one and this one, they're exactly the same. Okay? Because what matters here, guys, is being able to identify what is the base and what is the height. And how do you know which is the base and which is the height, guys? If you choose a side as the base, make sure you have a height that is perpendicular to that base. That's what's important here, guys. All right, let's keep going. And actually, I think these are good for you to actually, no, I do want to do one of these with you guys. Let me do number, or this one here on the left side. I need the area. So I need 1/2 base times height. Do I have a base? Yes, I do, right there. So I'm almost there already. 1/2 the base times the height. Ran into a snag. I don't have a height. How am I going to do that? Well, unfortunately, Pythagorean theorem is not going to help us here, guys. We're going to have to refer back to something that we've used in the past, all right? Look closely at what information you actually have, guys. You have one side and an angle. That is it. So, there is something here that we've used in the past, guys, that's going to be super helpful. Okay? According to that angle, this is the opposite side. Across from the 90 is always your hypotenuse, which makes this last missing side the adjacent side. Well, I'm looking for what this side is. Let me go ahead and call this x. I'm looking for the height. I want to know what this height is. So here's the question, guys. What uses opposite and adjacent? Because I have nothing here. There's nothing here at all, so that's not helpful. Okay, what uses opposite and adjacent? That would be tangent, guys. So we got to do some extra work here. The tangent of our angle, the tangent of 50 degrees is going to be opposite. Remember, guys, so toa. Opposite over adjacent. So what's the opposite? Opposite is x. Adjacent is 20. So how do we go about solving this? Well, just like we have in the past, guys. Go ahead and make this over 1, and we can cross multiply these. 1 times x is going to be x. 20 times the tangent of 50, I could just write it exactly like that. 20 times the tangent of 50 degrees. Go ahead and take a moment to type that into your calculator, and we should get, let me go ahead and type it on my own. I got 23.80, let's see, let's go ahead and run to the nearest hundredth. Let's say 23.84. And actually, you know what? I'm not going to do that. I'm not going to round just yet. I have warned you guys in the past not to round early, so I'm not going to do that. Let me actually show you guys how to do it. Let's agree on one thing. X is equal to 20 times the tangent of 50. That's exactly what I want you guys to write right here. Okay? So let's go ahead and do that. So the formula for the area of a triangle is 1/2 the base, and now my height, I just figured out what it is. My height is 20 times the tangent of 50 degrees. Okay? I want you guys to actually type this whole thing in your calculator exactly like you see it there. And if you do that, you're going to get, let's see, 1/2 times 20 times another 20 times the tangent of 50, and I am going to get an area of approximately 238 and 35 units squared. I'm rounding to the nearest hundredth, guys, but notice I didn't round until the end. That's why I actually want you guys to go ahead and enter this whole thing as your height right here. Okay? So if you can, try to avoid rounding twice, because if I would have rounded originally, I would have had to round again in the final answer, and we want to have as close to an exact answer as possible. Okay, I think I want to let you guys try this next one on your own, guys. So go ahead and pause the video for a moment, try out this last problem before we move on to the backside. Alright guys, so here it is. Go ahead and double check your answers. Hopefully you guys got something similar to what I got. What the important thing here, guys, is to remember this. This is an equilateral triangle. Why is that important? Because if it's an equilateral triangle, guys, then all of the angles are congruent. That means each of those are 60 degrees. That's helpful. Okay, so keep that in mind, guys. So let me do some erasing here. What is also important here? Well, what's important is we distinguish what our base is. I went ahead and called this my base, and it really doesn't matter which one you called your base. You could have totally done another one of the legs. But in this case, I just chose that side, guys. So what do I know? I know that my base is 8. Now, do I have a height? Well, that was the hard part, guys. We needed to figure out a way to figure out this height. I want you to notice that I found that it was 4√3. But how did I get that? Well, let's focus a moment on this right here. Because if you look at that triangle, guys, that I just highlighted there in blue, that is a special right triangle. That is a 30, 60, 90 triangle. Okay? Alright, if it's a 30, 60, 90 triangle, what do we know? Well, we know a few things from those. Across from the, and let me do it off to the side here, 30, 60, 90. Across from the 30 is the x. Across from the 60 is the x√3. And across from the 90 is the 2x. So did I have any of that information? Well, yeah. Check it out. I have the 2x. The 2x is 8. What does that mean? That means the x is, the x is 4. Well, if my x is 4, that's my short side. That's what goes across from the 30. So that means that across from the 60 should be the x√3. So 4√3, and that is how I ended up getting 4√3 here. So I have everything I need, guys. So my area, in exact terms, without any rounding necessary here, would be 16√3 units squared. Okay? Alright, let's keep it moving, guys. Let me try to see if I can wrap this video up pretty soon for you. But let's go ahead and take a look at this next scenario, guys. So it says draw a parallelogram ABCD with side lengths of 4 and 12 with a height of 6. So let's see. Here's a parallelogram. Let's go ahead and draw one. I think I have a nice little tool for that. Hey, look at that, I do. Okay. So side lengths of 4 and 12. And don't forget, guys, in a parallelogram, opposite sides are congruent, so all of these are there. Now it says, what is wrong with this parallelogram if the height is 6? And maybe I gave you a little too much information there, but let's figure it out, guys. Well, here's the deal. Let's go ahead and draw a height. Why not? Let's draw a height right here. So using this as my base, why don't I draw a height there? Or you could draw it over here, guys. It really doesn't matter. And I want you guys to think about this. If this height is 6, okay, what's wrong with this? What is the problem here? Okay, look at it really closely, guys. And actually, it might help if I zoom in here and I concentrate on just this portion. Look at it very closely, guys. I know that if it's not clear right away, I'm pretty sure you guys can figure it out if you really stop and think about what kind of triangle that is and what rule it's breaking. Okay, so I'll give you a moment to think about it. All right, and here it is. Check this out. That is 6. This is 4. This is the hypotenuse because it's across from the 90-degree angle. What has to be true about the hypotenuse in every single triangle? Well, the hypotenuse should always be the largest number, and in this case, 4 is definitely not bigger than 6. Okay, so there is something wrong here, guys. We cannot draw a parallelogram with these dimensions that still gives us a height of 6. So, okay, here's what I'm going to write. I'm going to go ahead and say using the height of the parallelogram, which in this case was 6, you created a right triangle. You created a right triangle right here. Okay. Now I'm going to use that triangle to come up with some sort of contradiction here. This height of 6, okay, which is actually a leg of the triangle, is larger than the hypotenuse of the triangle, which in this case was, 4, which is impossible. And that is why we can answer this question. What is wrong with this parallelogram? Well, what's wrong with it is this. It's impossible. You can't have those dimensions on a parallelogram, guys. Okay? Now, what is the area of a parallelogram? So we're talking about parallelograms, so we may as well talk about what is the area of a parallelogram. Well, check this out, and I'm glad I actually drew this picture now so I can prove something to you. The area of a parallelogram is actually, and here it is, base times height. Now this should be ringing some bells because you should be like, wait a minute, I thought that was the area for a rectangle. Well, it is. That's because a parallelogram, in terms of its area, the area that it occupies, it's pretty much the same exact as a rectangle. And let me try to prove to you why. Watch this, guys. Ready? Let's agree on a few things with my diagram here. Again, we agreed that this diagram is not possible, but I like this picture, at least, to help me prove a point. Ready? According to this, the base is 12, the height is 6. Okay, cool. Let's say that this was a possible parallelogram. Well, how is that the same as the area of a rectangle, or why is it the same as the area of a rectangle? Well, check this out. Let's say I deleted this piece, or better yet, let's say I cut that chunk out. Look at this gray triangle right here, guys. Let's say I cut that chunk out. Let's say I take this whole thing and I replace it over here instead. So let me put that big gray chunk over here now. So remember, I just erased it. I just took it from one place and moved it over to another. So it's no longer here. So let me erase it. Maybe you're already saying, oh, I can see where he's going with this. But I just moved it. I just moved it over, guys. Now what just happened? What kind of figure is this now? That's a rectangle. So what just happened? Guys, the area of a parallelogram is the exact same area as a rectangle. You still have base times height. What is important here, guys, what I will say right before we get any more confused, if we are, or right before we make mistakes in the future, okay, this was a right angle right here, okay? This was a right angle right here. Because those are right angles, this is a right angle. And this is a right angle. Why? Because it's a parallelogram, guys. It was a parallelogram, okay? Opposite sides in a parallelogram, or sorry, opposite angles in a parallelogram are congruent. Okay, so we've established the formula. Let's go ahead and apply it. I'm going to go ahead and do maybe 2 of these and let you guys do the last few on your own. So it says find the area of each figure. Okay? Well, here we go. By the way, this 120 degrees is this angle right here, guys. Well, let me go ahead and try this out. Let's do this as our base. Remember, I need area equals base times height. So area equals 14 times some height. Now remember, guys, the height has to be, okay, the height has to, oh, sorry, this isn't supposed to be 120. Do me a favor, guys, erase this. I don't like that it says 120. Let's make this 60 instead. I think that's what it should have said all along. I just forgot to change it. Make this 60 degrees for me. Okay, let's go ahead and draw a height, guys. So here's my base. My base is 14. Let's draw a height. Again, a height has to be perpendicular to the base. There it is. This is my height. Now, do I know what it is? No, not yet, but I'm pretty sure I could figure that out. Okay, and actually, might even be better to draw it over here. By the way, this 6 goes for this right there, guys. So maybe, again, let me try to redraw this over here. Let's put this 6 right here towards the inside. I could draw a height, like I said earlier, I could draw a height here too instead if I wanted to. Okay, it really doesn't matter, guys. What I want to make sure that you guys understand is this. This and this is exactly the same. Okay? So this is technically also 6. Okay, you could draw it wherever you want, where it literally does not matter, guys. But I like this one because I already have all the diagram and all the information in here. Maybe I could figure out what that height is based on looking at the little triangle created on the corner of that parallelogram, guys. And I can. Once again, we have a 30, 60, 90 triangle. So what do I have? I have the side across from the 90-degree angle. Remember, guys, in a 30, 60, 90 triangle, that would be the 2x. The hypotenuse is always your 2x. What does that mean? Your x is equal to 3. Now, that would mean this side is equal to 3, but I could care less about that side. I want to know how much is the height. So the height would be x root 3, or in this case, 3 root 3. Okay? And I know it might be getting a little confusing with all the x's and stuff. Maybe I shouldn't have used an x for this example, but let's just be clear, guys. This height is 3 root 3. Okay? So let's go ahead and wrap this up. I have a height now. My height is 3 root 3. So times 3 root 3. So what is the area of this parallelogram, guys? The area of this parallelogram is 42 root 3 units squared. Okay? All right, let's go ahead and try out the next one. See how much time. I don't want to make this one too long. All right, I might just end up doing... I think you guys can figure this one out, guys. All I have to say about this one is this. See these right angles, guys? I'm going to let you guys do this one on your own. See those right angles? Keep those in mind as I'm about to do this right here. Pretend for a second that I'm cutting this out. And instead of having it there, I'm going to put it over here. Okay? All I did was move this triangle. Okay? And I moved it right here. Okay? Why did I do that? Well, because if you look closely, guys, this is now a rectangle. Okay? That's now a rectangle. So all I need to do is find the base and the height, and I'm good to go. Okay? All right, now you didn't have to do that, guys. Again, absolutely do not have to do that. But if it's helpful, you can go ahead and do that. Now, remember, a base and a height are always perpendicular, guys. This is a good candidate for base and height. Okay? Here's the base. Here's the height. Area equals 1/2 base times height. Area equals 1/2 the base. Well, that's the hard part. What the heck is the base? What is this x? Well, let's establish one thing. If this is 17, so is this. And doesn't this look familiar? What kind of triangle is this, guys? 8 blank 17. 8 blank 17. 8, 15, 17. This is an 8, 15, 17 triple. Again, guys, Pythagorean theorem is your friend. You can use it. Okay? So, I have my base. My base is 15. I have my height. From over here, it was 8. So what is the area of this parallelogram? The area of this parallelogram is 1/2 times 15 times 8. If I am not mistaken, that would be 60. Oh, sorry. Wait, why am I doing 1/2? Sorry about that, guys. Base times height. I don't know why I'm doing 1/2. Sorry about that. Now, technically, 1/2 would be, I'm not all the way wrong. 1/2 base times height would be the area of this triangle, but I have 2 of them, so I don't need 1/2. I need a full one. Okay? So that would be base times height. So in this case, that would be 120 units squared. Okay? All right. Let me do which one? Which one sounds good here? Let me do this one. I think this will be the last one for today, guys. So, trapezoid. Well, the problem is we don't have a formula for the area of a trapezoid yet. However, look closely, guys. A trapezoid is just a composition of what figures? Well, if you look closely, that to me looks like a height perpendicular to the base. That to me looks like a height perpendicular to the base. What did I just split this up into? Well, one triangle here, a rectangle right here, and a second triangle over here. So what do I have to do here, guys? Well, I just have to find the area of all 3 of them. What is the area of this one? What is the area of this one? And what is the area of this one? So let's take it one step at a time, guys. What information do I actually know? Well, I'm going to go ahead and start off with the yellow triangle. Okay, let's start off with the yellow one, guys. Again, across from the 90 in a, look at it closely, 30, 60, 90 triangle, guys. Across from the 90-degree angle is my 2x. So what is x? X is going to be 8. That is what goes across from the 30. So this height right here, let me erase this real quick. This height right here is 8. Right there. Okay. What is the base? Well, the base would be what's across from the 60-degree angle. So what's across from the 60-degree angle? The x root 3. So in this case, it would be 8 root 3. So I actually have enough to find the area of that yellow triangle, guys. So I'm going to highlight it yellow here. The area of the highlighted yellow triangle is going to be 1/2 the base times the height, and in this case that would be, let's see, that would be 32, I believe, 32 root 3. Okay, 1/2 base times height. Cool. All right, let's go ahead and move on to the next one. Let's see. Let's do the, well, actually, why don't we do this? We said that this blue portion is a rectangle, right? Why do I know this? Well, I have 2 right angles there. Okay. Well, so this is a rectangle. Cool. That's great and all. But how is that going to help me for the area of the green triangle? Well, if it's a rectangle, opposite sides are congruent in a rectangle. So actually, this is also 8. Why is that helpful? Well, guys, look at it closely. This is a 45, 45, 90. In a 45, 45, 90, this is the leg. That's your x. What is your, that's your x. So the legs in a 45, 45, 90 are congruent. So I actually have everything I need. The area of the green triangle is equal to 1/2 base of 8 times height of 8. So actually this is going to be 32 units squared. Alright, and the very last one, what is the area of this blue rectangle? Well, that one's actually the easier one because we have a base and a height. So area of the blue is going to be just base times height. So 12 times 8, which is going to give me, let's see, 96 units squared. So what am I going to do here to finish off this problem, guys? I am going to add it all up. The total area is 96 plus 32 plus 32 root 3. That is going to give me a final answer of 128 plus 32 root 3 units squared. And yes, guys, you have to leave it separate like that, okay? This term does not combine with these two terms. You gotta leave it separate, okay? Alright, guys, I'm gonna go ahead and end the video at this time. Actually, that's perfect. It's still under 45 minutes, so still under what I would be teaching in class. So hopefully you guys are good now, guys. As always, rewatch the video if you're a little bit confused. I do want you guys to go ahead and try out this next problem all on your own. Just realize that this is 45-degree angle here. Think about it, guys. Isosceles trapezoid here. What do you think that means about this angle over here as well? Okay, other than that, guys, I'm going to go ahead and end the video here. I will talk to you guys in the next one.